Now what is a systematic linear block code? So in a linear block code, let us say we have n number of bits, and when we talk about systematic linear block codes, we have k number of message bits together and n minus k number of parity bits. So we can have the message bits either at the beginning of the code word or at the end of the code word. Let us take an example of a 6,3 linear block code and generate all possible code words. So the problem states that in a given systematic linear block code 6,3, where 6 stands for n and 3 stands for k. So the length of the code word is 6 bits and the length of the message is 3 bits. The parity matrix is given by this. Find all possible code words. Now, since the length of the message is 3 bits, how many possible messages can we have? So that is given by 2 power k, which is 2 power 3 equal to 8. So what are they? So it is 0, 0, 0 up to 1, 1, 1. All possible combinations, 8 possible combinations. Now, in order to generate all possible code words, now how do we do that? To generate all possible code words C, we have to multiply the data with the generator matrix. Now the code word is of length 6 bits, right? So this is a 1 cross 6 matrix. So data is 1 cross 3 and hence the generator matrix is going to be 3 cross 6. So you multiply a 1 cross 3 matrix with a 3 cross 6 matrix, you would get a 1 cross 6 matrix. So now, what about this generator matrix? The generator matrix G is of orders 3 cross 6. That means there are 3 rows and 6 columns. Now, if I want to place the data at the beginning, so for the generator matrix, which is 3 cross 6, I have the identity matrix of order k. So here k is 3, so it is going to be I3 followed by the parity matrix. So this is going to be 3 cross 6 because the parity matrix is of order 3 cross 3. So now you have the data and then you have the generator matrix. So the code word C is data into, I have the generator matrix. So you have 1 0 0 0 1 0 0 0 1 along with the parity matrix 1 0 1 0 1 1 1 1 0. Now the data is of length 3 bits because k is 3, isn't it? So let me write D as D1, D2 and D3. So the data matrix consists of 3 bits, so it is D1, D2, D3. So what is the code word? In the first case, multiply this with the first column. So it's going to be D1, the remaining are 0. Then the second bit would be D2 and the third bit would be D3. Because I'm multiplying the data with the identity matrix, I will get the data itself. So in this code word, the first 3 bits correspond to the data itself. The fourth bit, so you would get D1 into 1 plus D2 into 0 plus D3. Then the fifth bit would be D1 into 0 plus D2 plus D3. And the sixth bit would be D1 into 1 plus D2 into 1 plus D3 into 0. So you would get 0 here. So I get all the 6 bits here of the code word. Right. So using this, I can easily generate all the code words. So here when we add, we actually do modulo 2 addition. So in modulo 2 addition, 0 plus 0 is 0. 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0. A simple way, if there are even number of ones, then the resultant is 0, or all of them are 0, resultant is 0. If you have odd number of ones, then the resultant is 1. So we just have to count how many ones and zeros are there, and we can directly write the result. So how many code words will we have? We'll have 8 code words corresponding to each of the data. So let's see how we can generate that. So there are 8 codes. I have named it as CA to CH. The message vector 000 to 111 because K is 3, and I need the 6,3 linear block code. So in order to generate the 6,3 linear block code, there is no need for me to multiply the two matrices all the time, because I already have how I can generate the code word. The first 3 bits correspond to the message vector, right? So I can write the first 3 bits 000, 001, 010, 011, 100, 101, 110, 111. Next, the fourth bit would be the first and the third bit. So you need to perform modulo 2 addition. So remember, if there are even number of ones, then the resultant would be 0. If there are odd number of ones, resultant is 1. So D1 and D3, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, even number of ones, 0, 1 plus 0 is 1, 1 plus 1, 0. The fifth bit, D2 and D3, 2 0 0, single 1 1, single 1 1, 2 1s 0, 0 1 1, 2 1s 0. Next, D1 and D2. So D1 modulo 2 addition D2, 2 zeros 0, 2 zeros 0. For these two you have single 1, so it is 1. Again here you have single 1, so it is 1. 2 ones here, resultant is 0. Right? So we have generated all the 6 code words. So we have generated all the 8 code words. So for the message vector 000 to 111, these are the code words. Now again, why is it systematic linear block code? Observe that the first 3 bits of the code word of all the 8 code words correspond to the message vector itself. Hence the name systematic linear block. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further updates. Thank you.